नंबर ऑफ अटेंडीज देखा है, नंबर ऑफ अटेंडीज देखा है,
बच्चों नहीं देखा,
तब नहीं देखा।
अबे टाइम दिखाएगा।
Hello everyone. Since like everyone has arrived, okay, so hope you all are doing well and learning new things during this lockdown phase. All right, so let's start with a little introduction. My name is Hazelbert, and let me give you a brief about Microsoft Student Partners program at our university. We, the Microsoft Student Partners, as most of you might already be aware with, conduct various seminars and workshops to build robust tech community at the university. We are a team of 5 students, namely our senior Vivek Verma, Riya Mistry, Maliha Nan, Jainik Gadara, and lastly me, Hazelbert. Talking about today's webinar, we'll be going through the following topics: Introduction to Apache Spark and Azure Databricks by Riya Mistry, which will be followed by a little quiz. Remember guys, you need to enter your actual name during the quiz. But that's not the end. We have something more for you. Jainik will then guide you through the process of becoming the next MSP from our university, and Vivek will make you familiar with the benefits of the MSP program. The webinar will conclude with a question and answer session at the end. Throughout the webinar, keep an eye on the Q&A window. We'll be posting the link to the attendance form there. Now I would like to ask Riya to start with the session.
Great. So thank you, Hedu, for the introduction. So let's get started with the introduction to Apache. So agenda of the meeting event is like this. First, we'll go through the overview of the Spark. What are the components through which Spark is built? How the ecosystem of Spark works, and then we'll move around defining RDDs around which most of the Spark ecosystem works. And at the end, we'll see a demo using Azure Databricks, a service provided by Microsoft Azure for working with Spark. So let's get started. So to understand Spark, we first need to define what big data is. Generally speaking, big data is a term used to refer to the study and application of data sets that are too complex for traditional data processing software. Like we have too much of data that our single computer system can't handle. So we can't define any data to be a big data. To call a data to be big data, we need the 3 V components that to be satisfied by our data. Obviously, the volume, the size of our data should be large enough. Then the second V is the variety. The data we get should be from the different sources and of the different formats. And the last thing is the velocity, the speed with which we want to compute our data, we want to extract, and all the computations that we need to perform, we need them very fast. So if our data is large enough and we have gathered it from a variety of different sources, and if we need a fast mechanism for retrieving our data or manipulating it, then we can classify our data to be a big data. So to work with big data, our traditional computer system isn't enough, as we have limited memory storage and computation power. So that Apache Spark was invented. And as you can see, Apache Spark is an open source distributed processing system used for big data workloads. So what happens here is that instead of storing our data in the secondary memory and then retrieving it one by one, we use multiple VMs here and store our data in RAM so that we can access it faster. We have many RAMs, many virtual machines, and in that virtual machine, we store our data in memory, that is RAM. So we can extract it faster. We can perform SQL queries on that. We can create data pipelines, ingest our data using database, and also we can run machine learning algorithms, working with graphs or data stream, and much more. So the applications of Spark, where we can find our Spark to be useful. So there are 3 kinds of applications. That are, first one, we can define it as iterative, that is a step-by-step model. As you have some of you have started learning machine learning, and you have seen that there are one-by-one steps in doing a machine learning process, such as like gathering data, then cleaning data, and then adding it to a model, and then we find the accuracy. These are all step-by-step processes, and then again if some error comes, we again repeat all these steps. So in this type of application, Spark fits the best. Then there are interactive applications, like we write coding or codes which we run automatic, means we write our code and then we run it, and then again we want to modify our code, again we run it. These type of applications are called interactive, like SQL, where we extract our data using select clauses. These are all interactive type of applications. Then there are streaming application, where we get continuous data from there arriving from one stream. Say for example, we have Flipkart, and where a consumer purchases an item. So this happens anytime, right? So what happens here, Apache Spark, what does is that it gathers data whenever any user purchases an item, then that modifies the database, and from that continuously in this Apache Spark stream, the data gets modified. So there are three applications of Spark: iterative, interactive, and streaming applications. Now, first we'll get into the architecture of Spark. Spark, as I've said earlier, is a distributed computing environment. We don't have just a single computer instance. Our work is distributed on something called as a Spark cluster. And in that, we have one driver and one or more executor. So as an individual, we write our command, yeah, and the driver is a main code where we'll write our command, and that will be distributed on one or more workloads. Let me first give you a diagram so that you will understand it better. So here I have created something more interactive kind of thing. So the architecture of Spark is like that. Here is a client. We have a file that client passes to the driver, which is the main core part of the Spark. And from there, the file is partitioned into, let's say, 1, 2, 3, and 4 partitions. And then the driver sends it all to the worker nodes. So let's say partition 1 is given to worker node 1 and also to worker node 3. Similarly, partition 2 is given to worker node 1 and worker node 4. And similar wise, you can see. So instead of computing in memory here or in processing data here over here, the driver just collects what the need of the client is, then creates a metadata of the management of these worker nodes and partitions it, and these partitions are stored in memory by this virtual machines. And then whenever something is needed, the cluster sends this commands to this worker nodes. Worker nodes processes that query or any type of work in the executors and returns that data back to the driver manager. And again, the driver manager sends it to the client. And this way, instead of working as a single computer, we here use this all worker nodes and memory at the back end so that we can get fast retrieval. So I think you should be clear now. So yeah, each task that whatever we type or whatever commands we enter, Spark considers it as a partition, a job to run, and this job is again partitioned into tasks on each virtual machine or the worker nodes. So here you can think of as a a parent-child relationship kind of thing, that first the thing comes to a parent and then it transfers it to a child. Similar way, where we write our first code in the driver code, and then it driver code doesn't work anything, it just lets the data from the client and then sends it to the executor. Main code is run on the executor and then it sends again back to driver. So here, as you can see, we have a driver, which is a JVM machine on which our application runs. And because of the parallelism, we get a fast output. So in Spark, we have a two-level parallelism. First, the driver sends the data to the executors, and inside executors, even we have slots. As you might have recalled that in operating systems, we have processes, and in again processes, we have threads. So similar kind of thing. First, we have drivers. Inside that, we have executors, and inside executors, we have slots. So this way, a two-level parallelism is achieved, and the number of slots are determined by the number of cores or CPUs of each node. So generally, to work with the Spark, we should define a Spark context. Let's say we want to go to a friend's house. So what we need first? Of course, the address of our friend is much needed. So consider the Spark context as the address to our cluster, and the management of all the worker nodes, on which worker node which data is present, and the partition, all are stored in the cluster manager. And we don't need to handle anything like that what is happening at the backend. All that is needed is managed underneath cluster manager, and we are working with the Spark context is just like an abstraction, so that all the complex things are hidden behind the scenes, and we only need to work with our logic or code. So this is a workflow. Spark application developers write driver program to connect to a cluster of workers. The driver defines one or more RDDs. So this RDDs are the main component of our Spark, and we'll go through it after in the later slides, but consider right now RDD as some type of data type or a data frame on which we can perform actions and transformations. So driver keeps all the track of RDDs, whatever transformations we perform with them, and keeps a history of them. And with whatever transformation we perform on a single RDD, it creates a directed acyclic graph out of it. I'll show you what it means. So here execution start, that means we have loaded some data over here. We have performed a transformation, say map. Then we have again performed a transformation, say map or something, or sort, order by a collect, anything. We have filtered our data. So whatever each command we execute on a Spark application, it creates a directed map out of it. As it will not perform that operation at that time, we'll see something called as lazy evaluation at the end. So this idea will be more clear, but consider that for every code of statement or every line of execution, Spark creates a directed acyclic graph out of it. So the workers nodes are long-lived processes that can store RDD partitions in RAM across operations. So this all what we have defined, this mapping and the directed graphs, are all stored on the worker nodes partitioned equally. Now we'll see what the general architecture of Spark is. At the bottommost part, we have the libraries for running SQL commands. Then we have a library for streaming application. Then to work with machine learning algorithms, we have something called MLlib. This is similar to scikit-learn APIs, as you might have, some of you have learned that. And then we have something called GraphX, which works with a graph kind of data structures. And at the top of it, we have Spark Core APIs. This is like C library functions that by default we have printf, scanf statements in the C program core API. And to call or to work with string functions, we need to import that command. So similarly here, Spark Core API contains the basic commands that will run on Spark. And to work with the SQL queries, you know, to import SQL. For working with machine learning, you need to import machine learning library, somewhat like that. And on top of that, we have Apache Spark runtime environment on which a program will run. And above that, we have the languages which supports Spark. Initially, Spark was only developed in Scala. A little overview of Scala is, which is a functional programming language. Now, what functional programming is, you can define simply as something where a function gets an input as a function and also output something of called as function. So this will reduce a lot of work to store data coming out of function and then passing it to again functions, something like that. Then because of the Python being a very versatile language, it started supporting Python. To work with SQL, obviously the SQL language needs to be supported. Again, the R language is the best for data analysis and statistics, so they started supporting R language. And again, also it supports Java. So as many of you are familiar with Python, we'll go with Python. So what is Python with Spark is known as PySpark. As I've said earlier, Apache Spark is written in Scala, but to support Python, Apache Spark community released PySpark. It is similar in computation speed and power as Scala, and the PySpark APIs are similar to Pandas and scikit-learn. When we'll begin writing some code, you will see that it is a lot of similar to Pandas and the scikit-learn APIs. So working with Spark is pretty much easy, as you will get all the commands, but to understand the architecture, it's really important. So we have a master node, and then we have worker nodes. On the driver, we don't perform any operation. Driver just collects what client needs are, then passes to the worker nodes, and the worker nodes processes the data and returns the output to the driver code, and the driver code again gives the output to the client. This is how Spark works. So interactive PySpark shell. For interactive applications, we can use this PySpark shell. It will be similar to a Python notebook, Jupyter notebook, and it will help in fast interactive prototyping, as you will see. So to work with any kind of Spark application, we first need the entry point. As I have stated, to get to a friend's house, we need first friend's address. So SparkContext is the entry point to a Spark world. To connect to a cluster, we need SparkContext. And by default, we call this variable as SC. So let me get started with some demo on PySpark. So here, let's say I type Jupyter notebooks, Azure notebooks. This is something very interesting, as Microsoft Azure provides you the free Compute Azure notebooks where you can run all your projects without any cost. So this is a basic, it's similar to Jupyter notebooks. So we can create a new project with here. We can specify any name, demo, or like that. We can, if you want, we can create it public. So right now I'm not creating a public, as I'm already having one. And here I will create a new notebook. Okay, first I need to run this. Otherwise, okay, let me create a new notebook. I'm using Python 3. So I wanted to work with this because I did not want you to get bored with the installation part. So here by default all the libraries are already there, so we just need to import it. So let's say to create the Spark context, I'm calling from PySpark code. And I'm creating an instance of it. Initially, it will take some time. And also note that when we are working with small data sets that are easily compute on our local system, we'll see that Spark performs is less faster than our normal pandas and all framework. But with a very large data set, let's say 1 lakh or 10,000, Spark definitely is the best option. So now let's say I want to print the version. sc.version, which version? So we are currently working with 2.4.4 version of Spark. Let's say I want the Python version. sc. The command. So I've selected previously 3.6 version of Python, so it is showing me 3.6. And also I want to print the name of the master node. So I'll create a master. So it's showing me local as I've not defined any name. So this is perfect. So now, so we have performed this inspecting context and all things. We have checked the Python version, we have checked the Spark version, and we have checked again the SE master node. Now we'll see how we can load our data in PySpark. So we do not have anything called a list or a data type or integer kind of thing. To create a variable, we first we can create anything using sc.parallelize method. Because this is a distributed system, it will create a distributed list or anything whatever we define inside this method. So sc.parallelize, we have created a distributed list. Let's say I want to print what type of data is this. So as you can see here, PySpark.rdd.rdd. It is a type of RDD. RDD we'll see later, so you'll get more about it. And to print the data, we have something called collect method, which will collect all the data inside that RDD. Okay, so here it has printed all the data. And this collect is called action. What we have performed is we wanted to fetch all the data inside it. So this is a fetch action. Let's say we want only the first element of it. So we specify it first. So we have performed the first action on it and it has shown the first element. So also we can load our data, which is situated in the text file using sc.txt file, text file method, which reads file as a collection of lines. So after each line, it creates a new delimiter. So now it's time to see RDDs. So data file on disk, we separate it or we partition it into blocks, and then we pass on that block into different nodes, worker nodes. So the full form you can see in the next slide. Resilient distributed data sets. Resilient. The word R in the RDD is the resilient, which means the ability to withstand. Then comes the word distributed. Distributed means we are spanning our data across multiple machines. So whenever one machine gets down, we don't worry about that, as we have copies of that on another different machines. And the dataset stands for collection of partition data, example arrays, tables or tuples, etc. Also, once we define an RDD, we cannot modify it. It is an immutable distributed collection of objects. So like first we define in any language that x variable is equal to 0, integer x equal to 0, and then we in the next line we specify x equal to 1. This cannot be done with RDDs, as once we have defined it cannot be updated. If we redefine anything, then the previous data or something will be lost and the new data will be assigned. So as I was talking about here, as you can see that we have copied each and every partition here in two data sets. So let's say this worker node 1 goes down. So partition 1 and partition 2 from it will be lost. But we have that partition 1 and 2 in worker node 3 and 4. So this will not stop our application from running. And all the metadata about how many worker nodes are there, which partition is stored on which worker node, all this is maintained by the cluster manager. And it regularly checks the status of the worker node. Let's say every 3 seconds it sends a worker node to this are you alive kind of message, and if it doesn't reply, it considers this worker node as dead and creates a new one. So we were on RDD, and RDD is the main part of the Spark. Once you understand RDD, you have understood Spark, you can say like that. So this is what RDD is. We first define an RDD. We perform transformations on that. It will create a new RDD. Again, we can perform transformation on that. It is kind of a loop structure, and it maintains all the modifications on that, which is called lineage. As we have seen that RDDs are resilient, which means they are fault tolerant. So anytime a new RDD crashes or something, we need to get our data to a previous checkpoint, like something like that. So do not discard all this transformation that we have performed. It stores them in a directed acyclic graph. Let's say we have performed a addition of new column in our row, in our table. It stores as a new RDD, and then suppose a worker node or all the worker nodes are dead, it will roll back to this previous RDD. So for that, it needs to maintain the lineage. Then we perform some actions on RDD, like as I said previously, the collect or the first command are some of the actions, and finally we print our data or the result. So now let's create RDD. As seen previously, sc.parallelize method is the one way of creating RDD. Inside that you can add any list, or let's say here we have specified a string. We can type check what type of it. As we have done previously, it showed spark.rdd.rdd. We can even load external data files using sc.text file, and we can even create RDD from existing RDDs. From previous RDD, we can select some of the columns only we want. This is called filtering type of thing. Now we'll define something called as Spark session. So going to a friend's house, having the address is just not enough. We need to define our identity also. So we have the address, we went there, but what if our friend doesn't identify us and says, no, I don't know, you go away. So for that, we have something called a Spark session. We define what we are. And for each application, we have only one Spark session. So if we create a multiple Spark session, it will give an error. So for that, they have defined this builder class, and inside that get a create method, so that if the Spark session was not created previously, it will create a new one, and if it was created previously, it will fetch that data. So let's now create a Spark session. Okay, for that I need to import from spark.sql Spark session, and this is a convention also to define a Spark session as the name Spark, but you can give any name. So Spark session dot builder dot get or create. So it's already created, and there is something called a variable called as spark.catalog.list tables, and this will show you all the tables inside our RDD. What happened is, so it's meanwhile it's running. We'll see how we can read our CSV file. So this is just one method of creating a CSV, means reading a CSV file. We have Spark session, we specify .read.csv and then file name, and if we have headers file, then we can specify that header equal to true. So here it runs. So the Spark catalog list tables, currently we don't have any table, so it showed empty list. So now let's create a RDD, means a data frame. So Spark.read.csv. Let me see if I'm having any file here. So I have this COVID-19 data.csv file inside my project. So I'm running that, and I even have the header. Now I'm checking the type of data frame that I have created. So this is the data frame which sits on top of RDD. So we don't need to worry about the underneath how many partitions it's created, on which worker node it's created. We can directly perform a simple transformations on that. And as you can see, this is very similar to Pandas library. Now we'll see what the data is within it. .show method will print all the top 20 rows of our data. So we have number, serial number, observation date, province or state, and all these fields. Okay. So we have created a Spark session, we have read the CSV file, and we have also printed the data within it. Now we'll use some manipulating columns function. Let's say we want to print what are the columns inside our data. So it will show us all the name of the columns. Let's say I want to add a new column, df dot, then there is a command called with column. So I'll say the name of the new column is total, and the value it stores is df dot, let's say, death plus, let me check first. Yeah, it's deaths column plus I want confirm, and this will just work fine. And you see that this automatically means when I entered this shell, it ran very fast. So now let me show. It has again printed the top 10-20 rows. So this way, using dot with column, you can add new columns. You can even rename the columns. So let's say I want to rename df dot, then there is a command dot column with column rename, and I'm specifying the column name as dead, let's say, and I want to modify the column text, and it ran again. Again I want to put in the data. It didn't work. No. Okay, I need to check this out. It's reverse. Yeah, so first we specify the old name and then we specify the new name. So then our column name will be changed. And as you have noted this, that every time we perform any operation on a column or manipulate anything, we again redefine our value to the df variable. So why is it necessary? Because as I've said previously, these are immutable. RDD we create are immutable, we cannot change them. So whenever we modify them, we need to reassign so that the new value is stored in our data frame. So as like SQL, we perform where clause means filtering. We can do even that with our RDDs. We can also select some specific columns using RDD. So we'll do that. Let's say I only want confirmed, and I want dates, something like that. Just copy it. Print the data. So I selected only that rows. We're gonna also perform filtering kind of thing. Let's say I want, you can even do this df dot dead greater than 0, or you can also specify inside using string like dead greater than 0, and we'll show that. So here you can see there is no such field which contains 0 dead members. So it has changed this, means the filter has worked properly. Then you can also perform aggregations using group by clause. If we this group by is necessary for aggregations to work. If we do not want to group anything by column, we can leave this brackets empty, and then let's say I want df dot group by, and I want to count, or let's say max of dead columns. What is the maximum that people died? And it will, It is not a numeric. Okay, this is because I have not specified the infer schema. It has considered all the variables as string. So whenever, remember, if from the data type, as you can see here is a float, so we can do one thing called as infer schema that will automatically tell the Spark that infer the schema by reading it. So let's say here the observation date contains a date data type, so it will automatically infer that this is a date and not consider it as a string. So okay, again then this will have dead. That's now I think it will work. Yes, it worked. It showed the maximum that in a day people died at this much number. You can specify anything here called as a mean, max, count, all the aggregating options you can perform by dot group by dot the operation that you want. Then there are SQL queries. Let's say I don't want to learn this new methods or with column and all these things. So what you can do is we can create a temporary view out of this table. So let's say I want to create EF out a table out of it. To work with SQL queries, we need to create or replace temp view. Okay. Let's say I specify this table as Corona. And I run it. So now if we run that Spark dot catalog dot list tables, it will show us a temporary table named Corona created in our database. So now we can directly write our queries using spark.sql command, and inside this I can write my any SQL query like select from say Corona. It will print all the data. I think we need to specify show method. Yes, so it will run as same. So if we do not want to dot filter or use dot select command, you can directly work with the SQL queries. If you know that using dot SQL method, you just need to create a temporary view out of the data loaded. Yeah, so we have created a temporary table also. We have performed SQL transformations, and now we'll see some of the transformations that we perform. Remember that first from the storage we create an RDD, then we perform transformations, then again transformations, and at the end we print the result. Note that the transformation follows a lazy evaluation. This means that whenever I write this command dot filter or dot select, until and unless I want to print the data using dot show, it will not perform that transformation. This means, like, let's say we are told to write a journal and we know that we have to write the journal, but we wait until the submissions come or the deadline comes. And at that time only, before the submission day, we write our journals. This is something like that. Whenever we want our data or want to print that data, at that time only we'll perform all the transformations we had defined previously that created the directed acyclic graph. So what other things we can perform on a RDD? We can perform a map function, say for each and every variable or a member here, where we have an output function. This something called as one-to-one mapping. And here is the example below that we have created a list sc.parallelize method and 1, 2, 3 for the members, and we want a new RDD out of it using the dot map function. We have squared all the variables inside it using a lambda. Then the dot filter method, which we have operated earlier, you can do that also using this. It will not create a one-to-one mapping. It will only filter out the data which are greater than 2 here. Then there is something called as flat map function. It is a one-to-many kind of thing. Let's say we have defined hello world, how are you, two members in our list, and we want to split our data whenever we find a space. So here the hello world whole string is mapped with the output hello also and world also. Your how are you is mapped with how, are, and you. So it is a kind of one-to-many mapping. Okay. Then we have RDD actions. We can fetch the data. We can print only the first 10 values. We can print only the first line, and then we can also count how many rows are there inside our count. As seen earlier, let me show you again. What just happened? So using this data frame df.collect, I can print all the data. Then using df.first, I can print the first row. df.take, let's say I want only the first 10 rows. It will print the first 10 rows. And the end, let's say I want to count how many rows are there. So these are the actions that will let's say perform action, means operate on the data we have explicitly, and they will print and work. Great, so we have almost done. Now it's time to see the demo on Azure Databricks. And here let me just Azure.com. So this Databricks is the function or the service that is provided by Azure for working with Apache Spark. And as I'll show you in the demo, it's very great tool. We can create a new resource. And in the, let's say I'll type here Databricks. So this is symbol. I will create a new one. I have Visual Studio subscription. I'll use the live demo. I'll specify the name of the instance. And note that if only this Databricks services are available in the US, central US, otherwise a cluster won't be created. Then here's a available free 14 days free trial, so it won't cost me anything. So if the validations are passed, it will be created. Also, I wanted to show that meanwhile, this Azure Databricks service, as actually Apache Spark don't have a storage system, it is basically used for computation only. So whenever our data, we fetch our data from a hard drive such as this, a blob storage or a SQL database, and we split that data on the worker nodes or number of virtual machines, and it is stored in that RAM, and it stores there. And whenever our cluster is, let's say we ended our cluster, then all that data will be lost. So it is not a persistent storage. It is only for the best computation speed. So this Azure Databricks service, we can fetch our data from the blob storage, from other data services of the Azure, like Hadoop, Apache Kafka, SQL Data Warehouse, or Data Lake. And we can perform operations on it. And then we can pass on that data to machine learning services or streaming applications. Here we have a Power BI kind of applications. So like any applications can use that data. And The persons which use these services are the data scientists, data engineers, analysts, and whoever wants to use it. So let me check if the service is created. So it will take some time, and I wanted to show, I've already created a Databricks service. So after the creation of the service, this will show up, and I will say launch this workspace. And this Azure Databricks service is not something that Azure has made. It's a completely native service that it has collaborated with Apache Spark and then built that out of it. So it is a collaborative system. So once the service is created, it will show you this page, and this is something like a Visual Studio, something that type of applications on which we program our application. So to work with Azure Databricks, first we need to create a cluster. So using this, you can specify any name, demo, let's say demo 3 or 4, and we'll keep the remaining data as it is. Also, we have min workers and max workers. This is something like what if our data is too large that it won't fit on two virtual machines or something. Then it provides us with this enabling auto scale functions. But if we are sure that we will need our minimum workers to 2 and maximum, let's say we only want that our data is small, so we can use less workers. So when our data is small, it will work with only 2 worker nodes, and when our data is too large, it will automatically split at the back end or work with this 5 virtual machines. And also this is something important, like what if we do not perform any operations in 2 hours or 3 hours, then our cluster will be automatically deleted. Like after 120 minutes of inactivity, our cluster will be dead and all our data which we stored in our RDDs will be lost. So I'm keeping this right now as it is, and I'll create one cluster. As you can see, we have 2 to 5 workers with 28 to 70 GB RAMs, 8 to 20 cores, and 14 GB memory. So also this creating a cluster will take some time. So I already have one running, so I'm using it. And also the working directory, and let's say I want to create a new notebook. So first I wanted to show, I wanted to connect it with my storage account where I have stored my files. So you can create new storage account on that. I have already created one storage account in Azure. Inside I have this containers. Consider a container like a folder that I have created. You can create a new container by specifying a name. Let's say folder 2. I want no anonymous accesses. I'll create that. So it's successfully created inside containers. I can upload data from my computer. I can select file, and I can select any file inside it, but I won't be selecting it as I have already uploaded one file. So let me just go to folder 1, and I have this COVID-19, the same CSV file that I've uploaded here, and I want this blob storage or this storage file to be working in my cluster. So what I'll do is I'll first create a connection. I'll create a new notebook. You can easily mount that storage file in this Azure Databricks workspace connection file, let's say. And I generally prefer collecting or connecting the files using Scala as it is very easy. So I already have that connection string. So this container name variable specifies that my folder 1, I'm working with this folder 1, inside which I am having this COVID-19 data. So, and my storage name is Riya storage 123. So I also need to specify that. So I've stored it in the variable. In Scala, we define variable using VAL command. So the storage name, account name is Riya storage 1234, and this is called something as SAS token. Without this, I cannot access my file. So I think this token will be not working anymore. So let me create a new token. So by right clicking on this, we have something called generate SAS token. And I want say read permission, I also want write permissions or delete permission, and the remaining strings are as it is. And here is generate SAS token. So it will create this key, which I will copy from here, and I'll paste it in this variable. And this is the important key through which you will access your file. And this remaining are the URL and config, which we don't need to remember, as you can always find from the internet. These are just connection strings. So let me run this. So I've defined my variables perfectly. Now let's say I want to mount that data on my workspace. So dbutils.fs.mount, basically what this function will do is it will go to this URL which I have specified here using my storage account in the container name, and this blob core windows.net URL. It will mount that folder, it will go that folder, fetch the data, and it will put in this current directory. So this will give me a feel like that file is next to my notebook here only. So let me specify the folder name here as folder, let's say 6, and extra config means this all connection string commands. Basically we don't need to remember that, but this will connect my storage account which is on Azure with this Azure Databricks service. So as you can see here that each task we run, it classifies it as Spark jobs, and here it also says that it took 27 seconds to complete. So this is a good thing, like we can get time out of it also. Okay, how many seconds are our work needed. So it is already mounted. So let me create a new notebook, and this time we'll create a Python notebook. Give the name operations. Also note that this Azure Databricks service which provides a platform has already which is free for 14 days, but the clusters which we created at the backend, which needs the virtual machines and compute operations to work, so creating that cluster will cost you the money. So make sure you create the minimum time that inactivity so that it will not cost you much. Now I want to read the data. So let's say, and here I don't need to create a Spark context and all thing. It is already created by default. So Spark variable will be already there. I'm reading read.csv, and as I've specified during the creation /int/folder 6, I guess, and COVID, what was the name? COVID-19.csv. In this file, and run that. first time we'll create, it took 10 seconds. So there is a command called as cache. No, first let me show you that assigning with column command here. We created this total command out of it, and df dot that's plus okay df dot recovered. That is not present. Okay, first let me check what is it. Okay, I didn't specify that. Okay, the header command, it has inferred that data also as a row, and here also I'll use the infer schema that will automatically infer the schema. So this sees we have added a new column which needed the computation of adding the death column with the recovered column, and it just did that 20,000 rows in just 0.03 seconds. I mean, this is huge. And now let's say I'm counting the number of rows. I mean, what a great speed this is. In 0.03 seconds, it has already computed 20,000 rows. And now I'm counting the data. And it took 4 seconds to count the rows. I mean, for counting the rows only, we need to add or append the number of rows, means pointer, we need to update the pointer. And to operate on this computation means we need to fetch first that column and then the recovered column, and then we need to assign that column to again total. So this defined what is called as lazy evaluation, which I was mentioning previously, that until and unless there's some action, that count or collect action is formed, this data frame won't perform this action with transformation that I specified previously. And this has benefited, or this is the main reason why Spark has evolved such much. It is lazy evaluation. There's something called as df.cache function. So we know, or sometimes we are aware that we need to work with this data type for a much longer time. So what we do is, instead of again connecting or working with RAM, we can pull our data from RAM to cache memory, so we can get easy access from it. By default, this cache is not on, so it took 0.05 seconds. Again, this also is a lazy evaluation. So now if I do df.count action, then only it will perform the cache operation. And now it took 4.94 seconds as it needed to perform. Also, we can check whether our data is cached or not using this. So it defines truth. This means that we have our cache on. And this is useful only when we are sure that we need to work with same data again and again. If once we define our data and we've performed some operations and then we again loaded some other data and we have cached something, that is means meaningless. So if you are working or want to work with same data again and again, then it's a good thing to cache your data. And now if I run that same command, it will take less time. In 0.15 seconds, and first it took, I guess, 4.94 seconds. See the difference in the time which it took to perform the operations. Also, there is a method called df.rdd.get num partitions. This will give us that in how many partitions our data is divided. By default, it is working currently in only one worker node. So as this Databricks services, let's say, over, and Okay, so hope you have understood some of the concepts, and this is for the fun purpose that you play the Kahoot. I've developed a little quiz on that. So make sure that you write here your original name, as it is important for us. And I'm using this classic. You can open this www.kahoot.it and you can type this pin so that we can get started with this. Meanwhile, if you have any doubt, you can ask. Just see. Okay. So meanwhile, people are entering. I have a little homework for you all. You can search on something called as predicate pushdown, and you can see what that means. Something called as predicate pushdown. So are there anyone else coming? So or we can start. About this, who is this big bada boom? We cannot use that name. Please change that. Please use your real name. This. So I think no more are coming. Then I'll start. Okay. Okay. So first question is, identify the transform. Only one. And next. Is this not working? Is there any issue? Check. Which is the base engine of Spark? It's Spark core, which is the basic library in which all the basic commands are there. And to work with all this remaining, we need to import them first. Okay, Rutvik is stopping now. Method to filter data from data frame. Yes, all of the above. Because using spark.filter, we can specify our where clause or something like we want something greater than or something. Select will select specific columns, and this we have not seen, I guess. Select.expr. Using this also, we can filter our data. VG. What is Apache Spark? The question is, what is Apache Spark? Cluster computing, parallel, edge computing. Cluster computing. 0 correct answers. The fixed question, identify the service which you have used. Which is the service? Just Databricks, data lake, SQL warehouse, or HT Insight. Again. We have worked with Azure Databricks. Next. What is the full form of RDD? Come on, you should know this. What is the full form of RDD? Very nice. So you now. Next question is, how do we create RDDs in Spark? The methods to create RDD. Spark.parallel, Spark.RDD, or Spark.parallelize, or not any. It's parallelize, not parallel. There is no such method called parallel. Spark supports features that improves its performance. Which feature is that? Lazy evaluation, eager evaluation. Which feature is Spark support? It's lazy evaluation. Until and unless operation is needed or output is needed, it won't perform the transformations, and that is what is called lazy evaluation. Now, last second question. Which of the following is not supported by Spark? Not supported by Spark. Which language is supported by C Sharp? Yes, it supports Scala, Python, and R. It doesn't support C Sharp. And the last question is: we can have multiple Spark sessions in our driver. Is it true or yes, false? We cannot have multiple sessions. That's why that builder.get or create method was there. So let's see the final. Okay, who is this? The second and first is that's it. Runners of PG and okay. So that was all about Spark, and I think I've done enough as a starting so that you might be interested in that. So for any queries, you can contact us on this emails, any of us. And now the remaining session is about how to be a student partner. And I'll hand over to Jainik now. Jainik, are you there?
Yes, sir. Am I audible? Hello.
Yes, you are audible.
Okay. So that was interesting quiz, and thank you, Riya, for a wonderful introduction to the Apache Spark. So hello everyone, my name is Jainik Gadara, and I'm a beta badge MSP. So today I will be talking about new initiative started by Microsoft, that is Microsoft Learn Student Ambassador, which is an evolved version of what we are currently, that is Microsoft Student Partners. So Microsoft Learn Student Ambassador is a group of on-campus ambassadors who help students to develop their technical skills or career skills. So as the ambassador, you can organize events at your campus. You can host community hackathon. Community hackathon means regional, like for Gujarat or for India, that is community, or mentor other students for their future. So you can mentor or volunteer students for their bright future. This program is quarterly based, so every 4 months, after 4 months, they recruit new students in this program. And currently, this new program, that is Microsoft Learn Student Ambassador, is going to start in early July. So now let me brief you how to apply for Microsoft's Learn Student Ambassador program. So one of our MSP would be sharing a link in the Q&A or chat section. So go to that link. There will be a apply button. So for this, you require a Microsoft account. Means either it might be Outlook or Gmail. Any of them would be work. So log into that account and click on Apply Now button. So the first step would be related to privacy and policies. So please read it carefully. There are few restrictions, means you should be above 16, which we are. Then there are few rules and regulation just go through that. Then click agree, and on next step you will required to give your personal details like first name, last name, and email address. Submit that, and on the third step you will you require your educational details. So this program is for currently pursuing either BTech or MTech or PhD. So you should must pursue something to apply for this program. This is not for any pass out students and not currently not pursuing any degree program. So the fourth and the most important step is written sample. Due to these steps, many of the students do not give their efforts to fill this. So I would encourage you all to please go through that steps and please join us. So the fourth step is written sample. Here you will be given 3 questions, and from that 3 questions, at least one of the questions answer should be in form of video. So there are 3 questions and one of them should be answered in form of video. So the first question is, what excites you about technology and why you want to help other students to explore and learn? So this is a question. It can be in written form or it can be in video form. From 3, at least one of them should be in video. Others 2 can be in written form. So elaborate what you feel and mention precisely that don't give any philosophical answers. And if you have worked with any Microsoft technologies previously, mention that it would help you. Then the second question is, how would you take an technical concept and teach to the friends or peer that have never heard of it? So in this, I would advise you to take an technical concept, give an example and explain. So when I applied, I took this question as my video answer. Now the third question is something for marketing question. Means if you are hosting an event at your school, how would you get students to attend? So how would you attract? What will be your ideas? So this is also one of the one of good question to answer in video form. So answer these 3 questions and provide a video link in any one of which you have selected for video answer and proceed further. Then the 5th step is additional information like GitHub, Instagram, Twitter. You can fill that. It is optional. The 6th step is technical skills. Means what are your fields of interest, and like ML, AI, or data science, or Azure cloud computing. So you can check box. So now I would request interested students to apply soon and join us, because you do not have much time, because from early June it would start, and the names for the students who are selected will be published in first week of June. For any queries, we are here. Contact any of the MSP for any queries. Now I will request Vivek to share some exciting benefits which you will get if you become a Microsoft Learn student ambassador. So Vivek, are you there?
Yeah. Thanks, Jenny, for introducing me. Hello everyone, I am Vivek Parmar, a Gold Microsoft student partner from Dharma Sirsa University, Nadiad. Today I will be talking about why you should join this program and how it will be useful to you. Microsoft Student Partner is a worldwide community. We have more than 1000 MSPs from India itself. As an MSP, you will receive various resources from Microsoft which can help you in enhancing your technical skill sets. Then you can further share your knowledge with your fellow students, your colleagues, your classmates, and trust me, you will also get to learn a lot when you share your knowledge with them. We have been organizing various workshops from last 1.5 years, and when some students walks up to you after the event and tells you, hey, I have been working on this project and the knowledge which I got from today's event will help me a lot. And when you hear something like this, it gives you some kind of satisfaction. It's like an achievement for you. and the same student sends you an email or it appear in front of you when you are hanging out with your friends in college and says, hey, I was present in that workshop and I integrated that service in my project and now it's working perfectly fine. So thank you so much for hosting that event, and believe me, it's really a huge proud moment for you. I believe that there are three kinds of attendees. One who just attend the event, the second one who try to implement the things at home which they learned during the event, and the third one, my personal favorite one. They dive deeper into the advanced concepts and explore various new things, and sometimes even ask you a question of which you are not even aware of. And you have to say, let me go through that and I will get back to you as soon as possible. So yeah, you even get to learn new things. Apart from this, as an MSP, you will be in touch with engineers and developers at Microsoft. Like if you think that this documentation is not proper or the service is on Microsoft Azure is not functioning properly, then you can just directly share your feedback with Microsoft Azure engineering team. Isn't that amazing? That you can directly contact with the engineers at Microsoft. And being an MSP, you can interact with other fellow MSPs from all around the world. You can ask how they are running and managing their community, and you get to learn new things from them. So yeah, just apply for the program and start sharing your knowledge with and help your community. Eventually, rewards will come to you. That's all from my side. Back to you, Riya. I guess your microphone is off.
So currently there is also a mechanism called as we who are currently student partners can uh, tell them, or we can what was that, Vivek, are you there?
Yeah.
We can tell them to recruit them. What was that?
Yeah. So as an MSP, we have like we could refer someone of you. So if you feel that you are really passionate about and you have good knowledge of particular technology, then you can just reach out to any of us and uh, we will nominate you for this program.
So that is it from our side. Now, if you have any doubts, you can specify in the Q&A section, or we can conclude this event. And do fill the feedback form. It's essential for us. All your precious feedbacks are appreciated. So I think there are no doubts here. So we can end this session now. So thank you all for joining us and attending the seminar. It's a great pleasure for us. And if you have any doubts or don't want to post it here, you can always mail us directly from mspddu.com site, where our mails are already there, or you can also contact the Instagram DDU student handle and we'll definitely reach out to you back. So thank you all for joining us and take care, stay home, stay safe.